Okay, so looking at the bottom, we have this diagram. So this diagram is what we call the real number system. It's our numbers as we know them. If it's not a real number, it's something made up that you've never seen before, which is not a number. So it's two parts. Okay, what we have here is we have on the outside of the circle, we have what we call irrational numbers. They're weird numbers that don't quite make sense. Okay. So if you turn them into a decimal, the decimal does not repeat. The decimal does not repeat, nor stop. So it goes forever and ever and ever. Those would be such things as square root 2, pi. We've never found the end of pi. Okay. Square root 3, square root 7. Okay. Now the other definition is that an irrational number cannot be made into a fraction. But the biggest difference is that's not like a square root 2, square root 3 number. Now the opposite of irrational is what we have as rational numbers. Rational numbers are a little bit easier for us to handle. We can make a fraction out of them. So, for example, if we have square root 4, that actually equals what number? 2. Right? You can simplify. It's a perfect square. And so that as a fraction is 2 over 1. Right? All whole numbers we can make into fractions. So here we have what we call our integers. So we have this huge thing called rational numbers. Break that down to integers. Those are plus or minus whole numbers. So basically they're positive or negatives, but they're whole numbers. Outside, in our rationals, those are our fractions, and there are decimals. They can be positive or negative, that's okay. So if you have a decimal that stops or terminates, right, decimals that repeat, or stop. So 0.2 repeating, that's okay. Right? That's a rational number. Now inside integers we have just whole numbers. And we start at 0, 1, 2, 3, and go on. So there's no negative numbers. Inside whole numbers we have what we call natural numbers, and you don't really need to know all this stuff that much. There's a couple of nitpicky questions to get you thinking about in your textbook. For natural numbers, we start with 1, 2, 3, and go on. Okay, we don't start with 0 because a long time ago they didn't really get this concept of nothingness, right? Caveman wasn't too smart, so we just had natural numbers. So this diagram can help you remember it. Rational, integers, whole numbers, natural numbers. Inside out or outside in, whichever way you want to think about it. Okay. Let's go back up here to the chart then. And we'll fill out the chart. So our natural numbers are our counting numbers. Okay, 1, 2, 3, and so on. Anything that you can count. Our whole numbers are be 0 plus the counting numbers. So eventually we got smart enough to understand that, hey, you know what, 0 matters. So it'll be 0, 1, 2, 3, and so on. And then we started lending each other money, and we understood integers, which are positive / negative whole numbers. So we weren't that smart enough to understand decimals. Right? We were lending each other cows and goats and stuff like that. Eventually we got smart and invented money, and we had our decimals. Okay, and so that's part of rational numbers. Okay, so this one here is no decimals. So for rational numbers, these are what we call our perfect roots. Okay, so for example, square root 81, that equals 9, which equals 9 over 1 is a fraction. Okay, or 0.21, which equals 21 over 100 is a fraction. So you have to understand your decimal place and how to make it a fraction. So a rational number, you can make a fraction. And so the decimal stops or repeats. The biggest thing is to understand those are perfect roots. Okay. Another example would be cube root 27. If you do that on a calculator, that works out to be 3, a whole number. Okay. Then we have irrational numbers. The biggest definition is they are not perfect roots. Okay. So square root 18, square root 12, anything that's not a perfect square inside. So these ones, they cannot be a fraction. So that's our focus for today, is the difference between these two ones. We'll ask you some easier questions, but the focus is recognize whether it's rational or irrational. Real numbers, those are both rational and irrational. Okay. All right, so let's have a little look here. Have a look at the number. Let's inspect it. Number 1, we're looking to see if it's rational or irrational. What do you guys think and why? Rational, irrational, and why? Oh, let's pick on someone like Haley Spence. Where are you, Haley? There you are, Haley. What do you think?
Rational.
Why?
Because the number is 15.
Awesome. So you should write it as -5, 0.15 with a repeat bar, and that makes it a rational number. Now I'm writing RAT just so it's easier for you to see it, okay? Next one. What do you think? Jared?
Irrational?
Yes, irrational. It's not repeating. There's a pattern, right? There's 1 more 3 each time, but that's not what we're looking for. We're looking for just plain repeating. So it's irrational. Number 3. Take a guess. Michaela Porter. It's a 50-50 guess. It ain't bad, 50-50. Nope, it's 50-50. You got to guess.
Can I just take a random guess?
Absolutely. It is irrational. Do you know why? No? Well, if it was, it's because of this, right? It's not a perfect square. If that was square root 1, that equals 1. Then we have a fraction. But it doesn't. It's not perfect. So it's not 4 either, which would equal 2. Okay? So what you guys need to know is you need to have this memorized, or not memorized, but figure it out. 1 squared equals 1, 2 squared equals 4, 3 squared equals 9. What's the next one? Then, what's after 25? Or gee, what's after 25?
36.
Then, 81. Then, 81. right? 12 squared equals 144. So you should be able to come out with that pretty quick. Refresh your memory tonight if you need to. You should even do the cubes up to like 4 or 5, okay? Because you're going to need to know that in 2 classes. You'll be totally done if you can't come up with them. Don't have to memorize them, but be quick with them, okay? So this one here is not perfect. It's not a Mr. Barker number, okay? So this is going to be irrational. That's a joke, by the way, if you get it. Okay, irrational number, because that's not a perfect square, okay? Next one, what do you guys think? Rational or irrational? Oh. This part's repeating, rational number. I don't know what the fraction is, but because it's repeating, I know it's a rational number. Next one, hard to tell. Convert this one, please, into an improper fraction. So 2 times 4 is 8. 8 plus 1 is 9. 9 over 4. Well, square root the top. We did that last year. Square root the bottom. That's 3 over 2. Hey, both of them are perfect squares. So this is very definitely a rational number. Okay, because you can remove that radical sign. Square root 200, what do you think? Try it on your calculator. Have your calculator out. Try it. Okay. So some people go square root sign, then 200. If you have an old calculator, it's 200, then the square root sign, which looks like a check mark. 14.4, nothing's repeating. So this is an irrational number. It's not a perfect square. Okay? So sometimes you got to check them on your calculator. But lots of times you don't. Any questions about the difference between rational and irrational? Okay, so that's one part of your homework. You'll be looking at that. Turn it over. Now we're into radicals. Okay? So if they're unsimplified, then they are irrational. But if you can simplify, then they are rational. So the example would be square root 64 equals 8. Whereas this example for irrational would be like square root 28, anything. Right? You can come with whole different numbers. So what we have for radicals, you have your root. This here is your index. Okay. It tells you how many times the number has to be squared or square rooted or whatever you want to talk about. This here is your radicand. Okay. So radicals could be rational if they're a perfect square. Or cube. Or 5 or 6. Okay. We usually don't deal with those. Or irrational if they're not perfect. We just looked at that up top. How do you know a radical will be rational? If it can be completely simplified. Okay. So, I'm going to help you out a little bit with this. We're just starting to explore this, so don't be too scared about this. So here the index is a 2. We never write the index 2. You've seen it a lot when you do Pythagoras. Okay? So what it means is we have to break this number into 2 numbers that multiply together. Then we can take out a single digit. Okay? So that's kind of what we're looking for with our radicals. Now, if it's in a cube, what number multiplies itself 3 times to equal 8? Guess and check. It's got to be small. 1 times 1 times 1? No. 2 times 2 times 2? Kayla, what do you think? That one works, because that equals 8. So we can remove a single digit. Okay? Now this one's hard to do, so you want to use your calculator for that one. Okay, so you're going to look for a button that looks like that, or it might look like that. Okay, so I have an old school calculator. What I do is I enter in the inside number first, 3125. Then I hit this button here. Okay, so I press that button. Then I have to enter my index of 5. Then I press equals. Inside equals 5. Now, if you have an new calculator, you have to hit your index first. So 5, and then this will appear on your screen. Then 3125, then press equals. Okay, so if you actually see symbols and stuff on your screen, you want to use this method right here. Try it on your calculator right now. Don't worry, if you didn't bring your calculator, we can try this tomorrow. Or try it at home, but you have to be able to do this, right? I'm going to check on your calculator to make sure that you know how to do this. So you got to know, okay? Bring the same calculator each time. Okay, this one. This one you can break down to 60 times 60. So what does that equal? Equals 60. Right? Now the next one, these ones you want to change into a fraction. 81 over 100. Because this is the tenths and then the hundredths. So use a decimal value to help you. That equals root 81 over 100, which equals 9 over 10. Okay, square root the top and the bottom. Try this on your calculator, the square root 0.81. Try that as well. It should give you 0.9. Everyone able to do that on the calculator? Okay. Try next one. Any ideas what that will give you? Take a guess before you begin. Look at 0.81 gives you 0.9. I mean, root 49 is 7. So what do you think this is going to give you? From 4 decimals, you'll go to 2 decimals, I bet. Try it on your calculator and see. Does that work? Am I right? Maybe I'm just blowing hot air. 0.0049 square root. Hey, look at that. Okay, so it's a bit of a pattern there with your decimals. Okay, next one. Now for 7, it's interesting to note, this equals cube root negative 8 times negative 8 times negative 8. Because there's 3 negative signs, I can take out a negative 8. Okay. Scratch off 11 and 12. Write down square root negative 64. What does that equal? Try that on your calculator, see what you get. I'm going to check with Austin. What did you get? Oh, good excuse. Wait, Sierra, what did you get? You can't find it? Come here real quick. Michaela Peranto, how'd you get? Really? Did you put in negative 64? Really? Put brackets around negative 64. It's shift, that button.
Oh, shift.
Yeah, so let's try 81 cube root. There you go.
So you write this one and this one?
Yeah, inside one first.
Okay,
Yeah,
thank you.
no problem. Anyone getting something funny on the calculator? Because when I do that on mine, now mine automatically puts 64 negative square root invalid input. You know why? Because in order to get a negative number, you must have 1 positive times a negative. Right? That's the only way to get a negative number. And so this one does not exist. DNE does not exist. Or you can put a circle with a line through it. Okay, it does not exist. There is no answer to it. So be careful with your negatives. But notice this one's an even. 3, though, is an odd amount. So if you have an odd index, it's okay. So odd index is okay. Well, this one, 64 to the 6. Try that on your calculator. Anyone else having calculator issues? Come up real quick. Try that one on your calculator. And number 9, try and do in your head. It's this button right here, second function. Okay, so you go 64, and now you hit your index of 6.
Okay.
Try it yourself, okay? Anyone else? Okay. So let me try this. 64. This button, then my index is 6. Oh, what's going on here? Clear. 64, 6, 2. So this equals 2. So what that means, how can I write this? Right? How can I write 2 as a root with index of 6? How many would have to be inside? How many 2s do I need to write in order to keep the value the same? 6 of them. 3, 4, 5, 6. Okay. What about this? Cube root of 9 cubed. Well, that would be 9 times 9 times 9. That's what this cube root means. So what is my answer then? Well, 9, because I'm looking for 3 numbers to take out. Okay, 3 identical numbers. So really playing around with this definition. You're going to find your questions in your textbook, do that too. Some are a little specific, so don't be too concerned if you're like, what? Try and work through the vocab. Ask me if you're unsure. Okay, but don't be totally alarmed because we kind of go into more details here than we actually need to know. Okay. Next part, this you need to know. You have to be able to calculate without a calculator. So it's called estimation. Okay. So first of all, 2 root 8. What does that equal as a square root? How do you bring the 2 inside? Well, because the index is 2, you should have 2 of them. So that equals square root of what? Multiply them up. 2 times 2 is 4, times 8, 32. So we got to figure out the approximate value of square root 32. Now you did this last year. What's a perfect square above 32? And what's a perfect square below? Good. 49, which equals what? 7. Okay. So below 7 would be the number 6, so this must be square root 36. So what's the approximate value then? Well, here we're 4 digits away, and from 32 and 39 we are 10 and 7, we're 17 digits away. So we're not even close to 6.5, we're well below that. I'd say what? Oh, I'm doing this wrong. Oh no, he's messed me up. I'm going to blame you. Good, thanks. This one's above. So what's below? 25. Okay. Now we can do this. So how far apart are these numbers? 32 from 36, 4 apart. 25 to 32, they're 7 apart. So what's your estimation? 5 point what? Pavandeep. You don't know? Do you think it's like 4.3? Really? Because 32 is in between these numbers, so wouldn't our estimation need to be in between those numbers? No? 5.5? We could do 5.5, but that would mean this number's right in the middle. Is it right in the middle? Well, it seems to me like it's closer to this number. So take another guess. Sure. 5.6? 5.7? What do you want? You have no clue what's going on? No? Yeah. What do you think your estimation will be? For the square root of this.
30K?
Yeah. Sure. 5.8, 5.7, something like that. It's probably more like 5.7. Okay. Try and calculate real quick. What do you guys think? Now, it's not going to be super accurate, and sometimes it's really off. 5.65. There you go. Okay, pretty good. Okay, next one. Cube root of 70. Okay, so cube root of 70. What's a perfect cube above and below? This one you're going to struggle with a bit. Cube root of 125 equals 5. And so for 4, cube root of 4, I believe is 64. So what do you think this one's going to be? Look how close 70 and 64 are. So this should be close as well. What do you think, Atinder? Sure, 4.2 sounds good. Okay. Do we know this one already? Yeah. A and C are in the exact same spot. Okay. Okay, what about cube root 30? Well, cube root of 3 is 27. So what's the cube root of 4? 64. So what do you think this one should be? Jesse? Aren't these really close? So shouldn't these be really close? Sure. Try and calculator. 3.1. Okay. So 3.3 is a little high. Okay, 3.1, 3.2 is probably a bit better, but 3.3 is a little bit high. It's harder to do those ones accurately. Okay. Now the fourth root of 6. This one's really hard to do accurately. What's the fourth root of 1? Well, it's 1, right? 1 times 1 times 1 times 1 times 1 times 1, 1. So, what's 2 times 2 times 2 times 2? 2 times 2 is 4, times 2 is 8, times 2 is 16. So what do you think this will be? Maybe 1 point. Oh, let's go with Jordan Watkins. 1.2? Sure. Now these ones are really hard to do very accurately, okay? 1.56. Ooh. What? Did I do that right? 6, 5x, 4, 1.56. There we go. 1.5. So here we're off by 5. Here we're off by 10. Wow, crazy. Okay, so looking at the numbers, we got 5.7, 4, and 3, and 1. So let's go 0, 1, 2, 3, 4, 5, 6. Okay, use the letters A, B, D, and E. A, B, C, D, and E. Put them in the right spots, please. Go. Okay, there we go. So E, D, B, A, C should be on the same line. We'll use a comma or one high, one low, your choice. Okay, but you want to get the approximate value. You have to be able to estimate these. Absolutely. It'll be on the non-calculator section of your test. So if you're not sure what I did, please come up and ask a friend, sort it out. Any questions? Okay. So, I'll just pause.